All right, so good afternoon. This is David Raymond with our Virginia Cyber Range weekly workshop, and today we are going to talk more about networking challenges. So I'll briefly review the last couple of discussions about networking and CTF challenges, and then I'm going to walk through solving some other CTF challenges and see how far we get. This week was going to be about web challenges, I think. Anyway, it was going to be something about not networking challenges, but I just think that networking is really core to cybersecurity education. I think it's really core to CTFs. A lot of CTF challenges, even before you get to solving the actual challenge, there's some networking involved. You know, some PCAP analysis or some file carving or whatever, just to get some digital artifacts so that you can do something else to it. So I think it's useful to talk about CTF, about networking challenges some more. And so today I'm going to drill through a few more networking challenges on our practice CTF, and I'll tell you before I start the challenge, I'll tell you what I'm going to work on and what one approach might be for teachers to have students hack on the challenge for 10 minutes, an hour, whatever, and then come back, and if they solve it, great. If they don't solve it, then you can play them the appropriate section of this video to show how to get to it, how to solve that challenge. And I'll look at some different tools that you can use, and so hopefully this will be an informative session. We'll get a little bit maybe beyond Wireshark. So if you want to play along, if you don't have access to a Cyber Basics environment, then I will provide one for you. You just need to, so bullet number 2 there, bullet number 2. If you need a Linux environment, you can go to the Virginia Cyber Range login page. Don't click the login button, but click the thing that says, I have an invitation code, and then type in this invitation code, and that will get you access to a course in the range, and you can use a Cyber Basics environment that I provide for you. This invitation code is good until March 26th of 2019, so that's a week from today. If you're trying to get to it after that, then send an email to support@virginiacyberrange.org, and we will get you a new invitation code. You do need to go to vacar.io/practicectf. That is the CTF environment that we're using, and I'm going to go to that in a minute as we get to solving more networking challenges. If you don't already have an account there, click on the register link, and you can create an account and start solving challenges right away. If you have an account but you forgot the password, then go to the login button, click the reset password, and you'll get an email that will allow you to reset your password. Okay, moving along. Weekly workshops every week. The live version is Tuesdays at 1 p.m. and I think more folks are watching the recorded versions, which is great. They're out on our webpage, obviously at virginiacyberrange.org under the community button. If you want to see a particular topic, then send an email either directly to me or send an email to contact@virginiacyberrange.org, and we will put that topic in the queue for future discussions. So I'm going to quickly hit some news stories. I've been chided for spending too much time talking about the news, so I'm going to quickly hit a couple of news stories. If you don't want the news, then you can fast forward 10 or 15 minutes and go straight to CTF challenges. So this story I think is interesting, and it didn't receive the press that I sort of expected it to. This story is about Beto. Is it Beto or Beto? Beto O'Rourke. So he is a Democratic presidential candidate out of Texas, and there's an author who was writing a book about a hacker group called the Cult of the Dead Cow, CDC. This is a hacker group formed in the mid to late 80s, you know, sort of a loose, well, I don't know, a lot of these hacker groups were sort of loose organizations, but I guess the CDC had a pretty controlled membership, and from reading some of this reporting, it seems like they'd keep the membership at around 20 people, mostly located around like the San Antonio, Texas area, although there were other people in other parts of the country. The cool thing about these hacker groups was it wasn't so critical that they all be physically located together, because now we had the internet that we could leverage to allow these, you know, folks to interact with each other. But this story grew out of a book that the author of this article wrote, this Reuters article. So this guy, if you go to the article, you can see his name. I don't recall. I should have put it on the slide. Anyway, he was writing a book about this hacker group, the Cult of the Dead Cow, and he was writing about it because it was sort of, you know, some of this reporting says it was the first hacker group. It wasn't the first hacker group. It was maybe the first well-organized hacker group that came to some level of national prominence. They were sort of groundbreaking. They did some interesting things. You know, at first it was just a bunch of sort of technically proficient computer users who were a little bit counterculture. So these were mostly teenagers, but they were proficient with computers, right? Because you know, in order to join the club, you had to be able to get your computer onto a network. You had to be able to get your modem to connect to a bulletin board system, and, you know, multiple bulletin board systems, and so there's some level of buy-in, right? You had to first of all, you had to have a computer with a modem, and in the 80s that was pretty few and far between. You know, if folks remember back to those days, I mean, I had a computer in the 80s, and maybe shows my age a little bit. I had a Commodore 64 in my house. I had I was a big computer user, but I didn't have a modem. You know, I couldn't connect to other computer users until I went to college, in the you know, when I went to college in the mid 80s. Then I was on a network where I could get access to things over the internet. So early 80s, having a computer with a modem was kind of rare. I suppose towards the end of the 80s, maybe less so. Surely into the 90s, a modem was something that people had. It was a pretty routine thing. But of course, this is pre-World Wide Web, right? So late 1980s, early 1990s, the World Wide Web really didn't come into existence until around 93 or 94. So before that, you had bulletin board systems, and then you had services like CompuServe and AOL and a couple of others that were, you know, you could connect with your modem. They were sort of like the web, but they really weren't what we now consider to be the World Wide Web. And so CDC was, again, they were sort of counterculture. They weren't super elite hackers. At least all of them weren't super elite hackers. They were kids, teenagers mostly, did some hacking, and there was some amount of what we would maybe consider to be hacking that was related to being able to connect to bulletin boards across the country. Because if you were using your parents' phone line, for example, you'd have to make a bunch of long distance phone calls to get to these bulletin boards. And so a lot of these young people, through their hacking group partners, they learned how to essentially circumvent the long distance charges. And so that was sort of the entry-level hacking that most of these people did, that just about all of them probably did. You know, they simply circumvented the long-distance charges. But beyond that, they wrote a lot of essays, right? So this article talks about some of Beto O'Rourke's essays that he wrote. They called them T-files, and I think the T is short for text, like text files. So these things were just ASCII text, and there were these essays that they would write, and, you know, some of it you could sort of, you know, it's kind of the ramblings of a teenager. You know, I shouldn't poo-poo it like that. Some of it's probably good stuff, but a lot of it, I think, was just sort of a little bit nonsensical, just, again, to be sort of counterculture. You know, they sort of made some music, and they did get active in some of the early hacker cons. One of the first ones was this thing called HoHoCon, which was in Texas. DEF CON is an early hacker convention that is now, it's the longest lived one for sure. So HoHoCon, it was in December, so it had sort of this Christmas theme, and it was only active for about 5 years. DEF CON has been active for more than 25 years now. And DEF CON is turned into this circus. It's tens of thousands of people converging on Las Vegas, and not what it used to be. It used to be a handful of people, hundreds of people, or maybe thousands, and it was kind of, most of them sort of knew each other. Now it's this huge thing that is kind of out of control. Anyway, so CDC, they were some of the first hacktivists, and so they were using their hacking abilities to make sort of a political message. They were probably the reason that they became sort of famous was that and this is why they're really considered a hacker group, is that they released this tool back in the 90s called BackOffice. And BackOffice was a tool that, the name of it is a play on this Microsoft tool called BackOffice. And this is before Active Directory. So this is in the 90s. And Windows NT was just a thing, just becoming a thing, or maybe it wasn't even a thing yet. But you had Microsoft Windows operating systems being deployed to into businesses, and the original Windows systems were not designed to be enterprise level operating systems. They weren't. The modern Windows, even the desktop, even like Windows 10 and Windows 7, those are intended to be enterprise level. They're designed to be deployed to enterprises, and they can be controlled through Active Directory. And earlier Windows were meant to be desktop systems, and then Microsoft created this tool called BackOffice, and they added tooling to the Microsoft Windows operating system so that you could control this thing for an enterprise. And the way you controlled it was with this tool called BackOffice, which again was kind of a precursor to Active Directory, which is what we use now to manage large number of Windows systems. And these were in the days when Windows security was just really bad. Like Microsoft security was terrible, and it's night and day between how it was then and how it is now. I mean, Windows security now is much better, but back then it was really bad. And so this Cult of the Dead Cow, they created this hacker software called BackOffice, and it was basically software that anybody could use to gain control of just about any Windows system that they could get on the same network with. And they released it at DEF CON. There was a couple of different releases of it, but I think the big version was BackOffice 2000. That I think was released at DEF CON in 1999, and that kind of made them famous. I mean, that made Cult of the Dead Cow, sort of nationally recognized as a group. And so anyway, Beto O'Rourke apparently was a member of the Cult of the Dead Cow. It seems like from this reporting, he wasn't sort of like super elite hacker type. He kind of did the basic stuff. He got access to the bulletin boards. He wrote T-files. He was certainly friends with members of the group, and he socialized with these folks. He was actually in a punk rock band in his earlier days. So kind of a counterculture guy in his younger days. And so this was reported last Friday, I want to say, by Reuters. And again, there's a book that's going to come out, not about him, but about the group. And the way that the way that this whole story came out is, again, this author's writing a book about the Cult of the Dead Cow, and then he somehow figured out that there was a congressional candidate who was a member of the Cult of the Dead Cow, and this he discovered last year in 2018, before the elections. And the CDC members, some of them are now known. Some of them are fairly well known, actually. But but they wouldn't share information. They sort of kept this whole Beta O'Rourke connection sort of secret. They just didn't feel like it was anybody's business and didn't share the information, and they didn't want to risk his congressional run. And so actually Beta O'Rourke sat down with the author before the election last year and talked about his involvement. And but the catch was that the author couldn't release any of that information until after the congressional election. And as it turned out, Beto O'Rourke lost that election, but is still becoming, he's a presidential candidate for 2020 now on the Democratic side. Anyway, I thought it was an interesting story. Surprised it hasn't gotten more news, quite frankly. I sort of thought that, you know, there'd be people on the far right that would sort of jump on it and make it sound like he was some sort of a super criminal, when I really don't think that's the case. Okay, other news. I went and talked too long again. This is a story that just points to what do you do with your computer when you're done using it. So the story is a Gizmodo story from today, I think. I saw it today. Scary how much personal data people leave on used laptops, phones, researcher finds. So this story is by this researcher who spent about $600 in a day going around to used computer stores and buying some laptops and desktops, some removable media, some hard disks, some cell phones, found a whole bunch of PII on these devices. So then the question is, what do you as a user do about this? When you're done using your desktop computer, do you just throw it in the trash dump, or do you recycle it somewhere? Do you sell it? And if you do that, what do you do with the hard drives or whatever that are inside those things? What you should do is remove them and either hold on to them or destroy them so that somebody can't find your PII on those devices, right? So that's what I do. I remove hard drives on anything that I get rid of. In fact, I'm sure I have a dozen hard drives laying around my house. Some of them are still in laptops that are stuffed in cases in my basement because I'm either I don't know. I need to get rid of that stuff. But I never throw a hard drive away without destroying it first. Usually by drilling a hole through it. So I have an old power drill that plugs into the wall, and so it has the oomph to, you put a big bit on it, and you can drill through a hard drive platter pretty easily. Basic advice is if you're going to get rid of a device, then take out the hard drive, destroy the hard drive, throw it in the trash. If you're, if you're going to get rid of SD cards or whatever, just throw them in the trash. Don't sell them to somebody. Cell phones are a particular challenge, right? So if you turn in your cell phone, if you take your iPhone in to get a new iPhone, then they'll copy over your iPhone while you stand there, right? And it takes a little while, but that way, you walk in with an iPhone with all your apps and contacts, and you walk out with a new iPhone with all your apps and contacts. But then you hand your old iPhone to the guy, and it has all your stuff on it, right? So what can you do to avoid that? Well, what you can do is you can back up your phone at home. Then you go in. Then you do a factory reset. So set it all to 0, and instructions for that are easily available online. Then you take your phone. If you're going to trade in your phone, you take your phone to the Verizon store. You trade it in, get your new phone, take your new phone home, and then reload your phone from the backup that you did on your computer. And that's what I do. And I would encourage people to do that. And those instructions, again, are found online anywhere. Okay. Enough news. CTF. So we're going to talk networking challenges for next 30 minutes, 40 minutes, whatever. And these are slides that I talked about before, right? So networking is all about capturing packets to find a flag. I've done 2 sessions on networking challenges already. One of them was one of them was 2 weeks ago, so it would have been the 5th of February, and the first one was a week before that, so the very end of, or I'm sorry, 5th of March. So you can find that date on the list of recorded lectures, recorded discussions in our on our webpage, and then the first one would have been right at the end of February. So if you haven't listened to those already, I encourage you to do that. I went through these slides, talked a lot about Wireshark, talked about some of these other tools, and I'll come back to a couple of those tools, talked about display filters. Wow, my PowerPoint just died. I apologize for that. Well, my PowerPoint is coming back up. I'm going to go log in. Oh, I'm already logged in. So I'm in my Virginia Cyber Range account, and here's my weekly workshops course. I've had this Surface for a year and a half, and I'm not particularly pleased with it for cases just like this. Okay, while I'm waiting, I'm getting my Cyber Basics environment spun up. All right, that's not slideshow that I wanted. Didn't want any of those, huh? Okay, networking. Oh, look at that. All my old annotations are on this one. Okay, so I talked about Wireshark. Talked about display filters. Talked about different logical operators you can use in your display filters on Wireshark. We did an activity where we brought up some HTTP traffic and we logged in. So we went to the Virginia Cyber Range, turned on Wireshark, went to a web page in the Cyber Range, and then we looked at that traffic, and so we could identify IP addresses, we could associate IP addresses with MAC addresses, we could see what the operating system was of the web server, etc. So that's on the first networking CTF discussion. Talked last time about some common protocols, and then we went through some CTF challenges that use some of these protocols. And so now what I'm going to do is I'm going to go back over to the CTF itself. So I'm going to go to my Virginia Cyber Range. So my environment is ready now. And I'm going to log in. Student and student. And I'm going to open the CTF. And we're going to look at some challenges. So most of this time today is going to be spent looking at challenges. So vacar.io/practice-CTF. If you don't have an account yet, click register. If you do, click log in. Here, I'm going to log in. Type that password awful fast, didn't I? Okay, so networking challenges. So the ones that are green, we solved in the last couple of CTF networking discussions. So this time I'm going to delve into some of the ones that we didn't discuss, and we're going to use some of the tools that we talked about last time and the time before. So the first one we'll look at is this challenge called Fun with DNS, 30-point challenge. So what does that tell you about the challenge? It tells you that it is not super hard. It's not on the super easy end, right? It's not 5 points. It's not 200 points, 30 points. So it's on the easy end. So I'll save the file. Fun with DNS. Okay, so here's what it says. it says dig-x, then it has an IP address, right? Should be able to easily identify the IP address, 50.116.194.23. And it says from the PCAP, not the interwebs. Okay, so that means you want to do a DNS lookup, and you want to so essentially the PCAP, and you probably can sort of figure this out. The PCAP includes some DNS lookups, and one of the lookups resulted in 50.116.194.23. So what you're trying to find is the domain name that is associated with that IP address. So how did I make that connection? Well, I made that connection. Here's how I made that connection. First of all, the name of the challenge is Fun with DNS, so this obviously has something to do with the domain name system. And dig, this tool dig, I'll go to, well, let's do it this way. Let's open up a terminal window, and I'm going to say ManDig. Remember, if you want to look at what a Linux command does, you use the man is short for manual. So I did ManDig. Here's what I got. Dig is a DNS lookup utility. And here's the usage, dig. And then there's all kinds of command line switches you can use. If I say dig, www.vt.edu, whoops, .edu, whoops, wow, dig www.vt.edu. There we go, that's better. I did a dig on www.vt.edu, and dig acts like NS lookup. So back to our discussions of networking of many, many weeks ago, NS lookup www.vt.edu, and I get this very short and succinct answer. Tells me it used this server to do the DNS. You know, that this is the server that it is getting its answer from. This happens to be a DNS server within the Virginia Cyber Range, and what I looked for was www.vt.edu, and this is the IP address. It's returning the IP address. So a dig or an NS lookup will give us the IP address for a domain name, and dig does the same thing, right? So if I go back to my dig command, it just gives a lot more information. Well, maybe a lot less information. There's a bunch of stuff up here, but the important part is here's the question section. I asked for www.vt.edu, and here's the answer section. www.vt.edu is at this IP address, 198.82.215.14. Now, what a dig-x does is it does a reverse lookup. Dig-x 198.82.215.14. What that should tell me, well, I hope it tells me. So this tells me, this is a reverse lookup, dig-x 198. So I looked up that IP address, and what I get back is, this is the, so this device has multiple names. The www dot name is an alias. So the actual host name of this system is cmsw-prod.hosting.vt.edu. But this is sort of the important part. But if I did a dig-x 8.8.8.8, then what I find is this is Google's public DNS, right? So google-public-dns-a.google.com is at 8.8.8.8, and that's a well-known IP address owned by Google. People use it. People point their DNS to it all the time. So, so a forward DNS lookup is put in a domain name, get back an IP address. A reverse DNS lookup is put in an IP address, get back a domain name. So what this is saying is is find the DNS lookup that returned this IP address, and that domain name is the flag. And I already downloaded the thing, so now I'm gonna go to downloads, and it's called more packets. So I'm gonna say Wireshark more packets.pcap. This is going to open up Wireshark so I can look at it. So here's my packet capture, right? And I need to find, I need to filter out everything except for the DNS traffic. So there's a couple ways I can do that. I could say, we know that DNS traffic is UDP traffic, right? UDP.port. So I could say UDP.port equals 53 to get the DNS traffic. And that worked, right? I could also have just put UDP, or I could just put DNS in the filter bar here. Okay, so here's a bunch of lookups, right? So there's a lookup for github.com, and that returned 192.39.252.129. Is that what I'm looking for? No, I'm looking for 50.116. 50.116. Okay, so now I can go down the list here. Here's DNS lookup. Is that it? Nope. Is that it? Nope. Is that it? There's all kinds of DNS lookups for 52s. Okay, this is not a difficult challenge because I know exactly what I need to do, right? I need to find a case in which the A record result is 50.116. Whatever the rest of it is. And then I just put in this thing, I suppose, right? I mean, this has got to be the flag or this. But I got to find that particular IP address. And so, again, not difficult, but tedious. There's lots of 52s out there, 72. I could look at this for, 10 minutes maybe, and then I have to go through, look at it again because I might have missed it. So I wonder if there's a way that I can do this quicker. So let's go to do some Googling. Wireshark DNS. I don't know. Wireshark DNS query. How to filter Wireshark to see only DNS queries. I already did that. Analyze DNS with Wireshark. Okay, that might be interesting, but I'm not a big video guy, so maybe I let's see. Well, it's not. Is there like a? I think there's a Wireshark wiki, isn't there? Let's see here. Wireshark DNS. It's PDF. Wireshark. Is there a Wireshark wiki? Yeah, there we go. The Wireshark wiki, aptly named. Okay. Okay, so DNS. Those are some sample captures, filter reference. I found the display filter reference for DNS. Okay, so I'm drilling into more. Okay, this is perfect. This is just what I need. Okay, so what I want is, so if I go back to my Wireshark, I'm going to clear my display filter. I can type in over here. I can type in DNS, and this will filter out and show me only the DNS traffic. That's still a lot of stuff though, right? So what I want to be able to do is get more, is drill down a little bit more in my query so that I can, if I could figure out a way to put in, to format a display filter where I could put DNS something something equals and then the IP address, that would be a lot quicker for me to find that particular IP address and host name combination. So I'm going back to the Wireshark wiki. So this is all about this is the filter reference for DNS stuff, and you can find this also for any major protocol: HTTP, FTP, SMTP, SSH, et cetera, et cetera, et cetera. And so these are all the different ways that I can filter on DNS stuff. So I can look for DNS CAA flags, for example. I'm not even sure what that is, but I mean, there's all kinds of stuff. I could look for specific cert types in DNS traffic. I could look for canonical names, DNS traffic. There's all kinds of stuff that I can filter on DNS, and none of that is particularly interesting to me except for this, DNS.A. And an A record is sort of a primary host name to IP address lookup, right? So if I say DNS.A, and then what it expects as input is an IPv4 address, and that's the exact thing that I have, right? So what I think I might be able to do is I might be able to say DNS.A equals, and then I copy my, copy my thing here. Copy. I'm going to paste. Zoop. Okay, here we go. So this drilled down to exactly what I wanted, right? This is a few different DNS lookups. Here's the source address, destination address of the lookup. The interesting part here is the request response, and so 50.116.194.23, that's the IP address I'm looking for, right? That's the IP address I'm looking for. And it is associated with this d.turn.com or d.turn.com.akadns.net. So let's try here d.turn.com. And what do you know? There it is. So this is the A record that's returned. This is the canonical name d.turn.com.akadns.net, and you know, so this is I think turn.com is Turner Broadcasting, and the reason why you have a canonical name that has the turn.com and then akadns.net is this is so Akamai is a service that you know, large-scale hosting, load balancing, et cetera. So organizations like maybe Turner Broadcasting can contract with companies like Akamai to host copies of their web presence in different parts of the world to make it more scalable and easier for people to get to on the web, et cetera. So it returns a couple of different responses, but the important thing here is we were able to look up a specific IP address to domain name mapping in a large PCAP that contained literally hundreds, maybe thousands of DNS lookups. So we didn't have to look line by line, but we were able to quickly find the answer. Okay, so that is the solution to that challenge. So what I would do is I would tell my students, solve that challenge, and then then you can talk with them how to do it, or you can show them this video. Okay, let's look at needle in a needle stack. Here it says, the flag will be obvious when you see it. Needle in a needle stack. Flag will be obvious when you see it. Okay, so let's download this guy. We're going to save. Okay, so now I'm going to go to Wireshark. I'm going to say open needle stack. Whoops. Yeah, needle stack. That's it. Okay. Oh, and I still have this filter, so I'm going to kill it. Okay. Okay, so I just downloaded the PCAP, and here's a bunch of ARP traffic at the beginning. I suppose that's not surprising. Wow, a lot of ARP traffic at the beginning. A lot of ARP traffic at the beginning. Okay. Oh, there's some real. Oops, there's some real traffic. Okay, so this is this is FTP traffic. FTP login incorrect, user admin. Please specify the password. Oh, here's login incorrect. Okay, so they put in the password. User admin, pass. I guess this is the pass comment. Password that was entered by the user. So this is a failed login. Okay, another FTP. Here we have user admin. Password is 12346. Okay, and login incorrect. Okay, failed login. Okay, user admin, password 12345, and this will be login incorrect. Yep. Okay, so what does this look like? This looks like a brute force, some sort of a password guessing attack against an FTP server. Looks like somebody's trying to log in as admin, so the system is asking for the username, getting the username admin, asking for the password. Please specify the password. They're putting in. So this is password 1. So this looks and smells to me like, so user admin, password 123456789, 123456778. So if I was to guess, I would say that the John the Ripper. Yeah, okay. So I would guess that somebody's doing a brute force password guessing attack against an FTP server, and I'm guessing that they might be using the John the Ripper. Right, so it starts with 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, then password 1, then 1 through 9, then 1 through 8. So it looks like this is what's going on. I probably created this challenge. Honestly, I don't know. It would have been 2 or 3 years ago. So that's what it looks like is going on. Anyway, password guessing attack and bunch of failed logins. Okay, but it's not that many, right? So if you look over here at my progress bar through this packet capture, you could, you could search through all these, and I could even do something like this. I could say FTP or FTP data. So this filters out all the non-FTP traffic. So if I do this, look at this. This is not very much stuff at all. Login incorrect, login incorrect, login incorrect, login incorrect, login incorrect. So, yeah, these are all incorrect. Admin. Let's see if something jumps out at me. Looks like a multi-threaded password guessing attack. I'm looking for something that says like successful. Oh, here we go. Well, this looks like it could be the flag because it says, here, what was the hint? The hint was the flag will be obvious when you see it. And so here I am. This is the flag. Looks like this is the flag anyway. This bit of data right here, right? Is there a way I can copy that? Don't send passwords in clear text. Don't send passwords in clear text. Hey, there it is. Okay. Okay, so that one was pretty easy to solve. Huh? Might have been easier than the last one. So I wonder if anybody actually, it seems like one of these is going to be the correct password though at some point. These are all password. And I'll show you the lead. Oh, okay, here we go. Here's the red herring in this challenge. There's often a red herring. There's all these incorrect passwords, right? And here's the red herring in that here's a valid login by Dorothy using this thing called temp PW, login successful. So there's all this whole list of a couple of hundred failed logins, and here's the successful login. So this is where, this is a red herring, right? So a lot of these CTF challenges will sort of try to lead you down the primrose path, and what this one does is it like every one of the logins has failed in this capture, except for one is successful. So people will say, oh, okay, let's look for the successful login. They find the successful login. They find the okay, so this is DRR. So this is not admin logging in. This is DRR logging in with I don't know, temp PW, I guess. The reason that these things are all intermixed is because the you know, normally you'd see username and then ask for the password, then the password, then you see, you know, failed login, then you see username, then request for the password, and then the password. You know, you see them in sequence. The reason these are all jumbled is because these password guessers, you can cause it to run multiple threads simultaneously. So what you get is multiple attempted, essentially simultaneous attempts through the FTP server. So it's going to have multiple requests ongoing at the same time, and it's going to be answering them independently. But in the network, it looks like it's all jumbled together. So anyway, this particular challenge has this, go back up to it. It has this particular format for the flag, and you'll see this in a lot of different CTFs. You'll see there'll be a flag format, and this is one of the standard ones. The word flag, and then a curly brace, bracket, brace, whatever. And then the flag, and then a closed curly brace. And that actually, if you have CTFs that have a particular flag format, then there are some shortcuts that you can take. Now, in this particular CTF, the flags are of various different formats. Some of them are of that format, but most of them are not. I tend not to do that because it's not very real world, right? You're almost never going to, in the real world, the thing you're looking for is never going to say flag with a curly bracket, right? You're looking for some bit of information. You know, the whole intent of CTFs is to learn cybersecurity skills and you know, and to learn how to do real world stuff. In this case, we're digging through real world packet captures to find data, but that data is never going to be able to form flag, curly bracket, you know what I mean? So anyway, but when that is the case, when you do have a CTF that has a standard format like that, then there's some shortcuts you can take. One of them is this. I'm going to clear my filter, and I'm going to put in, I'm going to use, there's this Wireshark, there's a Wireshark command. Let's see if I can just put it, well, let me go up to the, it's contains, and I'm going to see if there's a search. Here's a search. Contains. Search, oh, really? That's kind of surprising. Let me do this. Wireshark contains. So I guess I'll go on this very top. This is in Wireshark, yeah. Wireshark description, filter syntax, comparison operators, search and match operators. Okay, so Wireshark has comparison operators, right? So I can say EQ, or I can say double equal, you know, I can use the double equal sign. So I could say things like TCP.port double equals 80, and that'll give me HTTP traffic, for example. There are also these search operators. So additional operators expressed only in English. And you can, and one of them is contains. The contains operator allows a filter to search for a sequence of characters expressed as a string, quoted or unquoted, or bytes expressed as a byte array, or for a single character. So here, for example, HTTP. So you say what the protocol is that you know, the higher level protocol. So HTTP traffic contains, and then here in quotation marks is a string value. So if I go back to my, okay, so this is an example of how I might use the contains operator, search operator in Wireshark. So I'm going to go to my filter bar here, and I know that this is FTP traffic, right? So I'm going to say FTP contains flag. Okay, look at that. There it is. So my search is my filter contains FTP, then the contains, which is a search operator, and then the word flag. Again, the flag comes from the flag format, and here this spits out my my flag value. I could even be more general than that. So this was looking for FTP traffic, and I searched in the FTP traffic because I knew that what I was seeing was a bunch of failed FTP logins. Of course, that could have been a bit of a red herring too, right? I could have had 10,000 failed FTP logins, and then I could have had some HTTP interaction that was the actual flag being exchanged. So you can be even, let me clear this filter, you can be even more general by saying TCP contains flag. Okay, so remember, TCP is a transport layer protocol. So if I say TCP contains flag, then that's going to not just identify FTP traffic, but that would identify the word flag in any application layer protocol. So that could be FTP, could be HTTP, could be SMTP, yada, 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 right? So this is a quick and easy test. If you have a networking challenge in a CTF where there is a specific flag format, then this is the go-to thing to do. You say TCP contains flag, or whatever is part of the flag format. So one more thing I'm going to show in this challenge, and we'll go on to look at one more challenge. When I talked about tools for solving CTF challenges that had network that were networking problems, I talked about this thing Ngrep, right? So Ngrep searches for strings in network packets, string SYN network packets. It's supposed to be over there, right? Search for strings in network packets. And so just like you can use grep to search for strings in files on a Linux file system, you can use Ngrep, network grep, to find strings in packet capture files. So let's do that. I solved that one, right? So I got the points. Okay, so what I could do is I could needlestack.pcap, so I can say ngrep flag needlestack.pcap. You don't have permission to capture packets on that device. Operation not permitted. Okay, so I did something wrong there. So this is the standard format of a grep command, right? You say grep, and then you have the string that you're looking for, and then you have the name of the file. But ngrep doesn't work that way. So if I say man ngrep network grep ngrep, here's my string. So this just means any ASCII characters, and then I have -io pcap dump. So that's the name of the pcap file, io. So what are the I? So I need to look at my command line. Switches. Okay, so -I input file pcap dump into the ngrep. -o pcap dump is output matched packets to packet compatible dump file. Okay, so what I want to do is I want to say -I. Okay, so here I said ngrep flag, so string. Then ngrep is a little bit different syntax than grep. With ngrep, I have to put a -I before I put the name before the input file. So ngrep flag -I needlestack.pcap, and it found the word flag, and there's my flag, right? So there are multiple ways to solve this particular challenge. Easy peasy. Okay, more networking challenges. Yeah, so we're getting close to time here. I'm gonna do one more, and let's go to our slides. I'm going to do one more because I want to show you. I'm going to talk about file carving, and I'm not going to do the file carving. I'm not going to do the actual file carving, but I'm going to show you a shortcut workaround that sometimes automates the file carving process. So what do I mean by file carving? We're going to take a look at a challenge in which, in order to get the flag, you have to find a particular file that was transferred in an email from one host to another. And that packet, that exchange was captured in a packet capture file, and so the goal in this challenge is to extract the an image file out of a PCAP, and that's way more explanation than you get from the challenge itself. So the challenge is named Rendezvous. And let me go to the, it's called, oh, where is it? Oh, it's not there. Okay. I'm going to do a thing real quick. I'm going to do a thing real quick. Bear with me. All right, I'm not going to do the CTF challenge. I'll do it next time because I don't know where it is. I thought I had it in the CTF, but apparently I don't. Let me look in one more place. Okay, I'll do this next time. So I'm not going to do the final challenge, but I'll just show you the approach really quick. Maybe next time I'll do some file carving. So we're looking for, so there's a technique that you can use to find files in packet captures, and you can pull out the file. You basically have to do some analysis of the data to figure out what kind of a file it is, and then once you figure that out, you can pull out the specific bits related to the file, and then you can put it in a hex editor and change the file extension and save it in the right format, and then you can open the file in the application of your choice. But Wireshark will do some of that in an automated way for you, so you don't have to. So that's kind of the old school way to do it, and Wireshark has some recently added functionality that does some of this automatically for us. So first thing you have to do in order to make this work is you configure Wireshark to allow TCP stream reassembly, and then so this is how you do it: edit preferences, protocols, TCP, and then you allow subdissector to reassemble TCP streams. I think this is the default configuration, so you may not have to do that. Then what you do is clear all your display filters, and then in Wireshark you go to Find Objects and Export, and then you click on File. Okay, so File, yeah. So in the File menu, go to Export Objects, and then it's going to give you a list of file types. The file types will be based on what kinds of file types what kinds of traffic that Wireshark sees in that particular file packet capture. In this case, it's an email file, so it's an email. So this thing will list stuff like HTML, and it might list FTP, and it might list email. So you select the protocol type, and then you select files to export, and you can either select individual files or you can export everything. And what this will do is it'll dump all of the files that it finds and can extract, and it'll dump them in a folder of your choosing, and then you can go into that folder and open the files and find the thing that you want. So again, we'll do this next time. Not going to try to get to today because we're way over time, but maybe I'll do both the file carving way and this way, and we'll see that it's we'll see the difference. It doesn't work every time, but it works sometimes, and it saves a lot of time. Okay, so thanks for joining us, and I look forward to continuing with CTF Challenge solutions next week. So thanks.